All right, today we're going to get started on one of the last lessons here that we have in Unit 3. And this lesson is over proving that two lines are congruent, are parallel. So I'm going to be on page 45 here. And here on page 45, we're going to prove lines parallel. Okay, and we've already talked that what happens if lines are parallel, what happens to these certain angle groups or angle pairs. Now we're going to look at if how to prove that two lines are parallel if I don't know that they already are. So let's say we have some lines here crossed by a transversal. So we'll have line L and line H, and we'll call this line K. Okay, and what makes lines parallel? Okay, so what would make line L and H parallel? Well, there's three things on our list. Before we had talked about that if these lines are parallel, then corresponding angles are congruent. So the first thing we're going to say here, let me switch colors, is that if your corresponding angles are congruent. Okay, corresponding angles are congruent, then your lines are parallel. The second thing would be if your alternate, interior, or exterior angles are congruent. Okay, so corresponding angles are the same, alternate interior, alternate exterior. If those angles are the same, then they're parallel. And lastly, your consecutive, interior, or exterior angles sum to 180. Okay, if that happens, then your angles or then your lines are parallel. So let's look at a couple examples here. All right, example 1. So we got this line, and this line. This angle here is 65 degrees, and this angle here is 3x plus 5. So the question might be, what value of x makes the lines parallel? Okay, so first you got to realize what line or what angles you have. We have corresponding angles here, and from right up here, to make lines parallel, corresponding angles have to be congruent. So this angle here has to be the same as this angle. So 3x plus 5 has to equal 65. And you might be thinking, well, we've already kind of done this stuff, but we did it in the other order. So I said that the lines were parallel, then we have to figure out what the angles are. Now we know the angles are congruent, or now we're trying to figure out what would make the lines parallel. So we're finding an x value. So it's very similar, just in a different order. So we're going to subtract 5. 3x equals 60, divide by 3, and x equals 20. Okay, so the only way that those lines are parallel is if x were to be 20. All right, the next one we have this is RS P Q. So they tell us that R is parallel to S. So R and S are parallel. And they also provide us this angle 1, this angle 2, and angle 3 here. They also say that angle 1 is congruent to angle 3. Show P is parallel to Q. Okay, so we're proving that these two lines are parallel. Okay, and I know that angle 1 is the same as angle 3. Okay, well, I've got parallel. If we just ignore this up here for now, I know that this line and this line are parallel. There's my transversal. So I know that angle 1 and 2 have to be the same because you have parallel lines, transversal, those are corresponding angles. So we're going to say angle 1 is congruent to angle 2, corresponding. Okay, so 1 and 2 are the same. And I already know that 1 and 3 are the same. So if 1 is congruent to 3 and 1 is also congruent to 2, then angle 2 is congruent to angle 3. That is the transitive. That's that transitive property that we've talked about a little bit before. So again, make sure you're looking over that valid list of reasons page. And then, so I haven't proved this yet. Then I can say that P is parallel to Q because these angles are the same. So alternate interior angles congruent. Okay, and then there's my proof. Again, we're starting to work our way into some proofs. Okay, and a couple things, just one thing here to remember. If angles specifically corresponding your alternate interior exterior if angles are congruent, then the lines are parallel. Okay, so important right there. There's the important part of the lesson today. Okay, need to know that. We could also have the transitive property with lines. Okay, so if P is parallel to Q and Q is parallel to H, then P is parallel to H. That would be the transitive property of parallel lines. Okay, so again, it's kind of the same thing that we've talked about before with the angle pairs, but in a little different manner. All right, thanks for watching the lesson, and I'll see you next time.